So I have divided the whole thing into mainly three parts. So today we will discuss all about energy part and how you will write the energy of some rigid body if you have. And then we will go for angular momentum part, conservation of angular momentum and all this thing. And after then we will just go for basically the torque equation and how you will write the torque equation. So these are the main thing you have to encounter with in rigid body dynamics. But before that, let's try to understand some basic definition, and then we will try to write the different, we will try to solve different problems. Okay. And this is one of the energy method is one of the very fundamental method, and you can use some tough question in very shortcut way. So we will discuss all this thing. Okay. So suppose we have some sphere. This is my sphere, and this sphere, this is the center of a sphere or center of mass of this particular sphere. If there is only translational motion, then every point of this particular sphere will move with the velocity of center of mass, isn't it? So this is velocity of center of mass. So every point will move something like moving with the velocity of center of mass. So what you can do, you can just replace the whole thing with your mass at the center of mass, and you can replace the whole particular rigid body as a point particle. But if you have something like, suppose you have a same sphere and it is rotating about the center of mass, let's say it is rotating about center of mass. So this point is not, this point has actually zero velocity, and we have some omega velocity, and that is angular velocity. So this is my angular velocity. And then we have at this point, we have velocity, and that is linear velocity. V is equal to something called omega r. At this point, we have velocity, that is V is equal to, again at this point, V is equal to omega r, and these 2 points are moving with the same speed but opposite direction, and this point will be virtually rest. So this is pure rotation. So this is known as translation. And this is known as pure rotation. Now what you will do, you will just try to club it these two. अगर इन दोनों को आप क्लब करते हैं, then what will happen? We have basically, now you can see this point is moving with the velocity of center of mass, and this point will move with the velocity of center of mass plus V plus omega r, something like this. So it will be some bigger vector. Suppose it is moving in this direction. So we have this value is equal to VCM plus omega r, and this point, these two, suppose we are talking about this point, so this will be go into this direction and this will go into this direction. So there are three basic condition can be there. So first condition, when omega r is greater than VCM, then what will happen? When omega r is greater than VCM, that means this velocity will be in this direction, isn't it?
Yes, sir.
है ना? So this is the condition when omega r is greater than VCM. The second condition will be, this will remain something like this, VCM plus omega r. This is moving with VCM, and if this condition will be omega r is less than VCM, then this will be in this direction, isn't it? And there is third condition, and this condition is very popular one. We have basically VCM plus omega r, and this point have VCM, and you have basically VCM is equal to omega r. So what will happen to this point?
Will be addressed.
That point will be at rest. So we can have this kind of situation. So this point will be rest. So this is basically this condition is known as mainly slipping. Okay. This condition is known as skidding. And this condition is very interesting, and this is known as rolling without slipping. So this is rolling without slipping. So whenever your VCM is equal to omega r, you will achieve the condition of rolling without slipping. So you don't have always this condition. Whenever you have this particular condition, then only you have rolling without slipping. Otherwise, you can have slipping condition or you can have skidding condition. So here you have more rotational velocity, then particle will move less in front in less translation motion. So that will be rotating more, but moving in a one particular direction, the amount of that particular thing is less. Here what will happen? Here the less is rotation, but they are just doing something like translation motion, such as in a skidding. In skidding, but here this point is assumed to be rest, but and your VCM is equal to what? Omega r, and this is basically rolling without slipping. So this thing you have to identify that which condition you are working for. But in general, you can see in your examination, this is one of the most famous condition where they will ask the question on basis of rolling without slipping. But otherwise, if they will ask question from this and this, they have to give what is condition of omega, what is condition of VCM, and then they have to give more information. Then you can use this particular thing. Okay. So now today we will discuss how to write the energy of any rigid body. So आप किस तरह से energy किसी भी rigid body का लिखोगे and how you will use it. This is very interesting. And you have solved a lot of problems into your wave mechanics also, this type of problem. So you can use this thing, this concept at that point also. So let us try to go for this, है ना? इसको देखते हैं. Mainly for JAM people, the net people can use this concept to write the Lagrangian, Hamiltonian, and all these things. Okay, so let's try to go for how to write expression of total energy of a system. And mainly when you are just working for the sphere, cylinder, and all about all these things. Okay, so what you have to do, the total energy of a system, and we are just talking about the conservative system. So if I am talking about conservative system, that means your energy is not a function of time, and the energy is conserved basically. So energy is constant. So suppose this is my energy, and this can be written as half, and you have to write the first kinetic energy, and then you have to go for potential energy. So what is kinetic energy? So when you will go for the rigid body kinetic energy, then you have to write first half m velocity of center of mass square. So this is all about the translation thing. And then you have to go for half ICM, and ICM is moment of inertia about center of mass into omega square. So this is a very general way to solve the problem. If you will follow this expression, your solution will be never wrong, and you can just go in a straightforward manner. So here we are not we have not concerned about which point it is going to rotate or something else. We have translation kinetic energy of center of mass, plus we have rotational kinetic energy about center of mass. We will just try to use this particular expression. And the potential energy part is all about, so in general, we will just use here for the gravitation. If gravitation is not there, then you can go for all other potential energy such as spring mass system. All the potential energy, nothing to do with the shape and size of the orbit. Sorry, shape and size of this particular body. Nothing to do with this. What you have to do, you have to just see how your center of mass is going to change. So once you will see your deviation of center of mass in any particular field or any particular potential, you can easily write this particular potential energy of a system. So in general, just I am trying to explain you. Suppose this is your rigid body and this is the point of center of mass. Let's say this is a center of mass, and this is the point where particle is pivoted, and or your particle is rotated about this particular point, and let's say this is your length L. Then you have to just see how this mass is going to change. You just forget all this particular shape and size of body. You have to just see how this mass is changes and how this, and then you can just replace it for the particle dynamics. Suppose you are doing some compound pendulum type of thing, then obviously this angle will be theta, and you can write your potential energy will be minus mg L cos theta. You can easily use this particular thing. So this is L, and what is L? L is the distance of point of position and between center of mass. If there is this type of problem is there where you have to use the potential energy, otherwise you have to just use the particle dynamics for writing the potential energy of a system, and your mass will be at the center of mass. This is the most important concept. Now, yes,
सर माइनस क्यों आया यहाँ
minus इसलिए आया है because we are just taking this point as a reference point. Okay, this point as a reference point, so this will be -1. Okay,
ओके
the potential energy will depend where is your reference point. It will depends on either you are you getting my point or not.
ओके
है ना? So I am just assuming this is my zero potential, so why this will be -1. Okay,
ओके सर
okay. So let's try to solve the problem. Unless until we will not solve problem, it will be very difficult to understand each and everything. Okay, so just straightforward, we are going to solve different types of problem. Okay, यहाँ तक clear है ना?
Yes, sir.
जस्ट प्रॉब्लम सॉल्व करते हैं तो अपने आप समझ में आ जाएगा. डोंट वरी, इसमें कोई थ्योरी नहीं है. यू हैव टू जस्ट यूज दिस एक्सप्रेशन नाइसली. ओके, now let's try to go for a rod. This is your rod. Okay, and this is pivoted at the end of this particular rod. Okay, and mass of rod is m and length of rod is L. So you can just assume this length is L. L is length. So what we have to do, we have to write the total energy of a system, and from using the total energy of system, we can also calculate the equation of motion. So let's try to go for writing the total energy, and then we will go for equation of motion. What is equation of motion? That is nothing but Newton's law, isn't it? Let's try to go for this. Now, what will be your duty? And this rod is moving in XY plane. So this is moving in XY plane, not in Z plane. Okay, so this is just moving in XY plane, something like a pendulum. So this is one of the good example of compound pendulum. Okay, now let's try to go for this. What will happen? So where is center of mass? At this point, I have center of mass. So your first duty is that you can put the value of center of mass as x and y. And assume this is your 0, 0 coordinate. The point of position is your 0, 0. So I can write this coordinate is x and y. Now, so what will be kinetic energy? The kinetic energy is equal to half m VCM square plus half ICM omega square. This is your kinetic energy. And the real challenge is writing the kinetic energy. The potential energy is not a big challenge. You have to just little bit of concepts to write the potential energy of a system. But here you have to write the kinetic energy of a system. So now let's try to write kinetic energy. What will be kinetic energy here? Half m. I can write this is x dot square plus y dot square. लिख सकते ना? What is velocity of center of mass? If this is your coordinate, then velocity of center of mass is x dot square plus y dot square.
Yes,
Clear है ना? Okay. Now, next is half. What will be ICM? क्या होता है रॉड का? लास्ट क्लास में
ml
करवाया.
square by 12.
square by
That
12.
value is ml square by 12. And this is your omega square. Now, look at here. Can I write x square plus y square is equal to l square by 4? लिख सकते हैं?
Yes.
लिख सकते हैं ना? Now, ये किस चीज का इक्वेशन है? सर्कल का. That equation is nothing but equation of circle. So that means your center of mass is moving in a circle. The locus of xy is nothing but the circle. और अगर कोई भी पॉइंट सर्कल में मूव कर रहा है, if any point is moving in a circle, then which coordinate system is the best coordinate system?
Circular polar.
सर्कुलर पोलर. कर चुके हैं हम लोग ये सारा प्रॉब्लम, है ना? सो नाउ कैन आई पुट एंड सर्कुलर पोलर के लिए आपको क्या चाहिए? लेंथ चाहिए और एंगल चाहिए, रेडियस और एंगल. यस या नो?
Sir.
रिमेंबर दैट पर्टिकुलर मोशन इन अ पोलर कोऑर्डिनेट. याद है सारा चीज? ओके. सो हियर this is my radius L by 2. So can I write x is equal to what? L by 2. And I can take this angle as theta. And we are making angle theta with vertical. Why we are making angle theta with vertical? Not with horizontal?
Equation of motion में जाके फिर वो problem create करता है.
With because of gravity.
Because of gravity. Because gravity is in vertical direction. So you are just trying to see how your system is moving under gravity. है ना? आप ग्रेविटी में देख रहे हो कि अगर उसका हम ग्रेविटी से एंगल चेंज कर रहे हैं तो क्या क्या हो रहा है. दिस इज द एक्चुअल थिंग. आर यू गेटिंग माय पॉइंट? So why we have to take this angle with the vertical axis. So what will be x? X is equal to L cos theta or sin theta?
Sin theta.
Sin theta. And what will be y? L by 2 cos theta. So I can write x dot as, क्या x dot की वैल्यू हो जाएगी? L by 2 cos theta, theta dot, and what is your y dot? Minus L by 2 sin theta, theta dot. सही है ना? हाँ या ना?
Yes, sir.
Yes. So we will just go and write half m x dot square plus y dot square is equal to L square by 4 theta dot square. Yes? and next term is half, that is ml square by 12. And what is omega square? Obviously, every point have same angular velocity, and that is nothing but what? Theta dot square. Yes? And if you will add it, the kinetic energy of a system is, you can see, half ml square by 3 theta dot square. Everyone is comfortable?
Sir, L square by 2 theta dot square आएगा ना ऐड करने के
कहां पर क्या करना है?
नहीं सर सही है sorry.
सही है? Okay. Now this is your kinetic energy, isn't it? Now अब आप एक चीज बताओ, what is this ml square by 3? ये क्या है?
Moment of inertia at the suspension point.
Yes, so this point is moment of inertia about the point of suspension. So this is your ml square by 3. But अब आपका ये क्वेश्चन होगा कि सर आपने इसी के अबाउट डायरेक्ट प्योर रोटेशन क्यों नहीं लिया? You can take it, but in some problem this will never work. ये प्योर रोटेशन का केस है. What is pure rotation? Pure rotation means point of position and center of mass have always same distance during the motion. Then you can use directly your moment of inertia about this point. But suppose करो कि कोई एक ऐसा प्रॉब्लम है, ये भी हम करेंगे मोस्ट प्रोबेबली कल की क्लास में. ये स्प्रिंग है और एक रॉड ऐसे है. This is your rod, and this spring can move in vertical direction. Then you cannot take moment of inertia about this point. Are you getting my point? समझ में आ रहा है आपको? आप इस पॉइंट के अबाउट प्योर रोटेशन नहीं ले सकते हो, बिकॉज दिस पॉइंट इज इटसेल्फ मूविंग इन अ वर्टिकल डायरेक्शन, और वहां पर सारे कॉन्सेप्ट आपके गलत हो जाएंगे. बट if you will go into this method, thus writing the first translation kinetic energy of center of mass and the rotational kinetic energy about center of mass, then this you will never do wrong. So आपका प्योर रोटेशन का केस हो या प्योर रोटेशन का केस नहीं हो, every time you have to use this one, you will get the exactly same thing. Are you people comfortable? समझ में आ रहा है मैं जो कह रहा हूं लॉजिक? मैं जब कल ये प्रॉब्लम करूंगा तो आपको मैं ये फिर से दिखाऊंगा, डोंट वरी. Everyone comfortable?
Yes, sir.
Okay.
Yes, sir.
Now, so we have write this particular kinetic energy. So once you will write kinetic energy, now let's try to go for potential energy. So when you are going to write the potential energy, what you will do, you will just change this whole system in a simple pendulum. Now, where is your mass? Where is your mass? At this point? Your mass will be, theoretically, your mass will at the center of mass, isn't it? So what we can do, we can replace the whole thing like a simple pendulum, and this simple pendulum have length L by 2, and this will be your angle theta. And what is your potential energy? Your potential energy is equal to minus mgy. I have taken this as my zero potential, so this will be y. So I can write minus mgy. And what is your y?
L by 2 cos theta.
Minus mg L by 2 cos theta. So this is your potential energy. So now you can write your total energy of a system. What is your total energy of a system? Is the kinetic energy and plus potential energy. So you can write this particular thing, half ml square by 3 theta dot square minus, and you can take big M because we are using big M. Okay, minus mg L by 2 cos theta. So this is your total energy. Yes. Now, from this particular total energy, you can easily go to the equation of motion if your energy is conserved or if your energy is constant. So here your energy is constant because there is not any time part. If there is any time part, then obviously your energy is not constant. Okay. So we have basically, now look at how efficient is this particular theory. So we can use dE upon dt must be equal to 0. लिख सकते ना? Because your energy is constant. If something is constant, you can write in this form. So now let's try to go for this particular calculation. अगर इसका मैं कैलकुलेशन करता हूं तो क्या होगा जरा देखो तो half ml square by 3 into 2 theta dot theta double dot होगा ना? Yes या no?
Yes, sir.
We are just differentiating with respect to time. और ये क्या होगा? cos थीटा को डिफरेंशिएट करोगे तो क्या होगा? sin थीटा. So plus mgl by 2 sin theta theta dot must be equal to 0. Yes? And theta dot is not equal to 0. So this 2 and this 2 will be cancel out. And you can take ml also common. So what do you have? You have you have L by 3 theta double dot plus G by 2 sin theta must be equal to 0. And for the small angle, if you just want to solve this for angular frequency for a small angle, I can write sin theta is near about theta. And then what will happen? You can write theta double dot plus 3 upon 2 G upon L. Theta must be equal to 0. So what will be value of omega? क्या आ रहा है? 3 by 2 G upon L. Clear है ये? And now this is nothing but the equation of motion. है ना? This is the equation of motion. Isn't it? Everyone comfortable? कुछ पूछना है तो पूछ सकते हो. Then we will go for next problem.
सर
हम्म.
तो यहाँ थीटा डॉट ओमेगा होगा ना, यहाँ थीटा डबल डॉट है ना.
Sir.
Hmm. This is equation of motion. Second order differential equation, isn't it?
Yes, sir.
And what will be the omega here? This is your omega, na? Do you know solving the simple harmonic motion? You know how to solve simple harmonic motion?
Yes, sir.
So this is the equation of simple harmonic motion, isn't it?
Yes, sir. Yes.
Huh? And that constant is basically omega. You can just go and revise your simple harmonic motion. Yes?
Okay, sir. Okay. Yes,
Okay.
sir.
Just try to equate that from there. Okay?
Okay, sir.
And this is your omega. Okay? Angular frequency. Everyone is comfortable? Okay, chalo. Let's try to go for next one. यहाँ तक clear है ना?
Yes, sir.
Okay. Now, let's try to go for a very basic problem, but very nice one. Suppose here is a sphere at the upper edge, at the here. So you can just assume there is a sphere. Okay. A sphere has mass m, radius r, and this distance is h. Okay. You can assume this angle is theta. Now the question is that what will be velocity of a sphere when it will reach the bottom of this particular wedge? If this sphere is executing rolling without slipping. Are you getting my point? The question is that, this is a very simple question, that this sphere is just going downward in a condition of rolling without slipping. Okay. So we have to write what will be the velocity at this particular point. And you can also assume that h is very, very greater than r, such that you can assume that this will be more or less at the h distance. The center of mass is more or less at the h distance. So how you will find it? The easiest, you can use it different way here, but we can go for the easiest way. We can use conservation of energy, isn't it? So initially the total energy is kinetic energy or potential energy?
Potential energy.
Potential energy.
Converted into
What will be that potential energy? mgh, because actually this will be mgh plus r, but h is very, very greater than r. So we can write it something like mgh. Okay. This is your basically initial energy, stored energy, something like potential energy. Now, this have to convert into the kinetic energy if it will reach here. Yes, the whole potential energy must be converted to the kinetic energy. Are you comfortable?
Yes, sir.
Yes.
Yes, sir.
Now, so now this is our rigid body. So what will be your kinetic energy? Half m VCM square. This is your translation kinetic energy or kinetic energy of a center of mass. Yes or no?
Yes, sir.
Plus, what you will write? Half I center of mass into omega square. Are you people comfortable? Now, here we have to calculate the linear velocity. And what is condition of rolling without slipping in this case? What is condition of rolling without
equals to
slipping?
R
equal to
mu.
omega r.
Yes, so VCM is equal to omega r. And what is value of omega from here? VCM by r, isn't it? So this value is half m VCM square plus half ICM. And what will be ICM? And assume this is solid sphere. What will be ICM?
2 by 5 mr square.
Exactly, that will be 2 by 5 m r square. And what is omega? We can write this omega as VCM square by r square. And now you can see this r square is cancelled. You can take half m VCM square common 1 plus 2 by 5, isn't it? And that value is what? 7 by 10, na? 7 by 10 m VCM square is equal to mgh. So what will be your VCM? So VCM is equal to what? 10 upon 7 GH. So you can see the role of moment of inertia. You can see the role of rotational dynamics, you can see the role of this particular moment of inertia. Suppose this will just slide down, then what will be velocity? Suppose it will be just going to slide down, then what will be velocity? Not doing the rolling without slipping. So you can just assume this is something like a point particle, and this value is equal to just exactly this one, isn't it? जो हम लोग क्लास 10th में किए हुए हैं, है ना?
Yes, sir.
But you have some extra term, and this term is due to the rotation of a system. So you can easily, and you can see the role of moment of inertia will come into picture. आ रहा है ना? This will come into picture. So always try to figure it out how you can use conservation of energy, how you can use moment of inertia, but the mother equation is all about this one. कुछ पूछना है तो पूछ सकते हो. Then we will go for next problem. चलो आगे बढ़े.
Yes, sir.
Okay. Now this one is very interesting. Look at here. So suppose this is a circular track and vertical circular track, something like this type of track is there. Okay. And this is your origin of this track. This is circular track. Let's say this radius of this track is R, and there is a cylinder, and you can assume solid cylinder of radius A and mass M is moving on this particular track. It is just moving on this particular track. But this cylinder is executing the condition of rolling without slipping on this particular track. Okay. So what we have to do, when it will make the angle theta, with vertical, what will be expression of total energy of a system? And once you will write the total energy of a system, you can easily go for equation of motion also. Okay. So what will be the total energy of a system? Obviously, kinetic energy plus potential energy. This is again conservative system. So there is not any role of other thing. So only you have kinetic energy and potential energy. So what is your kinetic energy? बताओ क्या होगा? Half m VCM square plus half ICM omega square, isn't it? Now what we will do, we will just put it origin at this point, and we have to give the coordinate of this point. What is the coordinate of this point? Let's say this coordinate is x and y. So what will be kinetic energy? Half m, and this value is what? X dot square plus y dot square. होगा ना? Velocity of center of mass. Yes or no?
Yes, sir.
Yes. Now half ICM. What will be ICM? You are rotating about
By
this
2.
axis. What will be this?
MA
M
square by 2.
square by 2.
MA square by 2. Now, what will be your omega? Is that theta dot square?
No, sir.
No. So what will be omega? What will be omega? बताइए. ट्रिक है व्हाट इज
x
ओमेगा?
dot square plus y dot square by
हाँ, बाई
a square.
by a square. Very good, very good. So what will be omega? Omega is nothing but x dot square plus y dot square root under whole square by a. Isn't it? VCM is equal to omega into a. And now here you have to take this particular a. And here is rolling without slipping. So VCM is equal to omega into a. And what is VCM? VCM is, this is nothing but VCM square. So VCM is just root under of this one. Very good. But the real challenge is that you have to write each and everything in term of theta. हमें किसके टर्म में लिखना है चीजों को? In term of theta. So we have to go to the next step. How we will go to the next step?
सर्कुलर पोलर में कन्वर्ट.
Exactly, very good. So what you will do, you can write x is equal to something r minus a cos theta. लिख सकते ना? हाँ या ना? सेंटर ऑफ मास तो ऐसे ही मूव कर रहा है ना? x and y is
Sin
the
theta.
yes, sorry.
Sine.
Good. Sin theta, very good. And you can see the center of mass is moving in a circular path of radius r minus a. यही हो रहा है ना? हाँ या ना?
Yes, sir.
Yes. And what will be y? R minus a cos theta. And from here you can got x dot, that value is r minus a cos theta, theta dot, y dot, r minus a minus sin theta, theta dot, and you can replace each and everything in term of theta. So this value is what? Half m r minus a theta dot square plus half, and you can see this a square and this a square is what? Cancel out, है ना? And you have half m by 2. Again you have r minus a theta dot square. क्या आ जाएगा ये वैल्यू? 3/4 है ना? 3/4 m r minus a theta dot square. So this is your kinetic energy. Clear है ये? Everyone is comfortable? सोच लो देख लो. Don't worry. So now we have to go for what? Writing the potential energy. What will be potential energy? Anyone?
Minus mv r minus a cos theta.
Yes. What do you have? So potential energy is equal to V theta is equal to, or Vy पहले लिख लो, that will be minus mgy, because we are choosing this one as my origin. So this will be as a lower potential. So, and we can take capital M minus mg r minus a cos theta. And now your total energy is equal to 3/4 m r minus a square theta dot square, and total energy is minus mg r minus a cos theta. You can see. So you can find the equation of motion from here. निकाल सकते ना? Yes या no?
सर
Yes.
हाँ.
सर
बताओ.
काइनेटिक एनर्जी में थीटा डॉट स्क्वायर आएगा लास्ट में या थीटा डॉट आएगा?
थीटा डॉट स्क्वायर ही तो है. आपको दिखाई नहीं दे रहा है क्या?
ये सर दे रहे हैं.
हम्म.
जो सेकंड टर्म है उसमें r माइनस a थीटा
सब
डॉट
जगह
स्क्वायर.
अरे थीटा डॉट स्क्वायर ही होगा, सब जगह स्क्वायर होगा. आप करके देखो साथ में, है ना? ओके,
ओके सर.
है ना? So let's try to write the equation of motion from the energy, है ना? क्या होगा बताइए? You can use d upon dt. यूज कर सकते हैं या नहीं? कर सकते हैं. So this will be 3/4 m r minus a theta dot 2 times theta dot theta double dot plus mg r minus a sin theta cos theta का minus sin theta. So this will be plus and theta dot must be equal to 0. अब यहां से क्या क्या कॉमन ले सकते हो?
r minus a bracket square आएगा ना फर्स्ट टाइम में.
हाँ, स्क्वायर फर्स्ट टर्म में स्क्वायर आएगा. यस. सो क्या क्या कॉमन ले सकते हो? दिस 2 and 2 विल बी देयर. यू कैन टेक m r minus a थीटा डॉट को कॉमन ले सकते हैं. हियर यू हैव 3/2 r minus a theta double dot plus g sin theta is equal to 0. This cannot be 0. Theta dot cannot be 0. R minus a cannot be 0. So this term have to be 0. है ना? Second term आपका 0 होगा. Okay. So from here you have theta double dot plus 2/3 g upon r minus a sin theta is equal to 0. This is your basically equation of motion. And if your sin theta is very small, you are just assuming it is very small, you can find the value of angular frequency for the small oscillation. What will happen? Sin theta is approximately theta. So you can write theta double dot plus 2/3 g upon r minus a. Theta is equal to 0. So omega is 2/3 g upon r minus a. Everyone is comfortable?
Yes, sir.
So now you can see this is just a straightforward thing. What do you have to do? You have to fix origin. You have to see what is center of mass. You have to write the coordinate of a center of mass with respect to origin. And then you have to use the basic definition of kinetic energy and potential energy. You have nothing to worried about which type of motion is going to happen. Is that pure rotation or not, or something is there? You have to just straightforward go for this type of problem. ठीक है? So should I give you one homework? करोगे उसे?
Yes, sir.
है ना? So just try to do this homework. So this is a circular hoop or ring, and this ring has radius r and mass m. This ring is pivoted at this point O. Okay, इस point पर pivoted है. And this is just oscillating in a vertical plane. Vertical plane में ये oscillate कर रहा under gravity. Okay. So what do you have to do? You have to write the total energy of a system, and then you have to find the angular frequency. हो जाएगा आपका?
Yes, sir.
है ना? Just try to do as a homework. ठीक है? So just try to do this as a homework. Tomorrow we will do some more problem, and also we will complete the angular momentum and conservation of angular momentum. Once you understand this thing, you can easily use conservation of angular momentum. एक और क्वेश्चन का आंसर आप तैयार करो.
सर
मेनली हाँ बताओ.
यहाँ अपने जो इंटरफेस वो 0 क्या मतलब
ये
क्या है?
पॉइंट फिक्स है. यहाँ पर एक फिक्स है ये. ठीक है?
Okay.
है ना? ऐसे करके फिक्स कर दिया, ये ऐसे ऐसे जा रहा है. ठीक है? कैसे बताऊं मैं आपको?
नहीं, मुझे एक्चुअली क्वेश्चन ही नहीं मिला, मेरा इंटरनेट चला गया था.
ऐसे सपोज करो ये ऐसे फिक्स है, ये ऐसे ऐसे जा रहा है. ठीक है?
Okay. इसके
Okay.
अलावा हमें ई और ओमेगा निकालना है.
हाँ, ई निकालना है और ओमेगा निकालना है. सेम थिंग. पहले एनर्जी निकालोगे और फिर क्या करोगे? डी अपॉन डी टी करोगे. यू विल फाइंड द ईच एंड एवरीथिंग. ठीक है? चलो. सो इसे आप करने की कोशिश करो. कल हम लोग थोड़ा सा लेवल कुछ ऊपर करने की कोशिश करेंगे, एंड देन वी विल go for conservation of angular momentum also. ठीक है? So
Yes, sir.
fundamental is that आपको सारा ध्यान कहाँ रखना है? किस पॉइंट पर सबसे ज्यादा ध्यान रखना है?
Third point पे.
Sir, CO.
Center of mass.
Center of mass. You have to give all focus on center of mass. How your center of mass is going to change? So you have to first fix the coordinate of center of mass. After then see what is the next story. You can easily convert that story into this particular expression of total energy is equal to kinetic energy plus potential. And what is kinetic energy? Half m VCM square plus ICM omega square. ठीक है? अब आप जरा एक क्वेश्चन का आंसर देने की तैयारी करो. हो सकता है ये आपके गेट या जैम के एग्जाम में आ जाए, है ना? यहां पर सेम पोजीशन पर एक स्फेयर है, एक रिंग है, एक डिस्क है. हु विल रीच फास्टर एट द बॉटम? ओके, हु विल रीच फास्टर एट द बॉटम? क्या क्या दिया हुआ है? स्फेयर, रिंग एंड सिलेंडर. देन हु विल, दोनों का रेडियस, सारे का रेडियस r है और मास m है. दिस इज वेरी इंपॉर्टेंट क्वेश्चन फॉर जैम एग्जाम मेनली. गेट के लिए भी आप देख सकते हो, मे भी नेट में भी दे दे, कोई भरोसा नहीं है. ठीक है?
Yes, sir.
सॉलिड स्फीयर और
वो मुझे पता है, तुम्हें आंसर पता है, मुझे कैलकुलेशन चाहिए. मुझे आंसर से कुछ लेना देना नहीं है. आर गेटिंग माय पॉइंट?
सर सॉलिड स्फीयर की हॉलो स्फीयर
सॉलिड स्फीयर, सॉलिड स्फीयर. ठीक है? ओके, चलो फिर. थैंक यू,
Thank you, sir.
थैंक यू.
Thank you, sir.
ठीक है, ठीक है. बोलिए.